So let's do it. And this, I think, would improve a little bit water quality, but let's see. So we go back, we just do our run.
Just before you do that, do you have to go back to your control file and tell it that you want the water column to go back to the 1 meter per day so that you can shoot?
I did it already.
You did that already? Sorry, I missed that.
Yeah, I did it already.
And what's the significance of the -7.1?
What -7?
The switches you're setting?
You're only requiring one CPU.
This, this is a parallel computation. You can the one number you can use 32. That's what I'm doing. I do all the time with 32. You can use another number, but 30 we just do the 30 box model so fast we don't need to use more than one.
Okay. So that essentially turns off the parallel processing.
Yeah, exactly. These are things when you have a very simple models. If you do, more table CPU, it's slower because they just like that.
There's overhead involved in breaking it up. The overhead overloads the savings.
I think this is. I think we may be glad we ran this, or maybe we're going to get in a lot more debates about what.
Okay, that's fun.
This is going to be
Okay,
interesting test.
We should run pools, the way it's going to do.
What?
We should run pools.
This time kind of slower. Somewhere it's working things. Okay, it's done. It's done. It's done. I think it's everything the same. We just go to the post-processing. I just run it. 27. Is 27? Yes, 5. Okay. So anyway, they are there. Then we just open it. I think this time is overwritten already. So before doing that, I think I need to close this one because it can't open two files with the same name. Disregard. Transfer finished. Okay, basically I'm doing the same things, and if you can relax, I think, but it's great if you do it. Finished. We are looking for 25th. Then go back to our base case. Oh, I have an idea. Like this, right? Like this. Okay. Like this. Like this, we just replace this one. We just doing exercise, right? I thought we put it here, but we can put it there. It did not work. Oh. It did not work.
So it's similar, but not the same.
It's not the same.
Actually, a little
Not
worse.
quite the same effect.
What are you supposed to be
But
better?
not as much.
Yeah. Okay. Yeah. Okay.
And the reason for that is that you have not eliminated as much of the oxidation in the water column.
So which is the new sensitivity run? Will we change?
Yeah, I think I did a two.
I think it's the blue.
No.
Take it back.
I think I want to do something. I'll go back. Just do too fast. I think I put it here better. Put it here. What? What the same number? Is it the same number? No, it's not the same number. So now this was the one that we just did. We just changed it to AB.
You can put all three of them on.
Yeah. That's a good idea too. So, yeah, you're right, yeah. Wow. Wow. Okay. I didn't understand, but this is the result.
No, I mean, so oxygen goes down, but it's not as severe as it was when we changed settling to the water.
Yeah. I want to check something.
Dan said you're just really, in that particular case, just dragging it out of the bottom layer more rapidly, where before we were moving everything down. Now we're just taking out what gets out of the bottom layer.
Yeah.
So you actually, you might have had a gradient before that went like that. Maybe now we got a gradient that takes the stuff in. Interesting.
So what I'm doing now is return everything to the base case, right? Oh, based. What's that? Okay, that's fine. To do next exercise. Okay. Now I think we are all set. Okay, so we just stay here and probably do another one. And number 6. Oh, this one you can talk about that how the open boundary would influence inside of the bay. That's you did it. So change N and P in the open boundary. And basically we needed to go to the first, which first? In the control first. Yeah. If you run, one example, I think it's good enough. If you are tired, just watch me, to do it, right? Because it's the same, right? It's the same. So I think that this one is here. I just do another one. Rename it the base. Okay, that's the base. So I need to read this, what I wrote. Okay, it's 927. Okay, basically this the kind of, reduction of carbon, nitrogen, and phosphorus at the open boundary. It's the same as Carl did this one. Huh? Do you remember? Carl did this one. So now we do this one, basically. But the different things, this one reduced the nutrient loading from the watershed, but this just check another, the open boundary, how it's influenced. So what we want to do, reduce by half. Okay. This one use the full things, we just use half of it. So see. Sorry.
So you want to take a guess as what the pool does?
Probably better should be, right? We don't, but I think, yeah, maybe. So water quality.
Fold, because you're reducing the organic matter that's coming in.
Yeah.
But you're also reducing the inorganic
yeah.
which go the other direction. So that'll be an interesting one.
Okay, yeah. That's the, kind of distributor you just talked about.
Which of these reductions apply to what? Red Sea.
Open boundary. So, but the ocean boundary has organic matter coming in, which, reducing that gives you a benefit because you're not going to generate as much algae, but at the same time you're reducing the inorganic nutrients, which are consistent more nutrient limited maybe, and will reduce the production. So the question is, what's the ratio of the organic matter to inorganic matter?
Yeah, sure. Let's see first, let's see if there are any signal.
This is the diffusion across the boundary?
Yeah.
This is reducing the boundary concentrations.
Okay. Gotcha.
Yeah, basically you are right. It's, so now we are ready to run.
I'm sorry?
Shouldn't that just reduce the concentrations across the board?
Yes, but if you reduce the organic concentrations, that organic matter, particularly organic carbon, creates an oxygen demand. So you're reducing the oxygen demand from the organic carbon, which will drive the oxygen up, perhaps.
Yeah.
And then actually the inorganic, you're reducing that too, which will make it more nutrient. So the DO ought to go up, I'm sorry.
Yeah.
Right.
Yeah. So while you are talking, the computer starts to work,
We're just arguing about the results before we see them.
No, excellent. What we
Which is actually a good way to build your intuition.
Yeah.
This one,
At oxygen 20, I'm ahead of you this time, 27?
yeah, I'm just, to, I kind of want to see with this one, kind of interesting though. See it. See it. Okay, put it there. Result DO result. Okay, that's fine. Okay, we save it. Okay, now what we have here? Yeah, it's run. Basically, we just go to the post processing. We just run it. 27 and 4. Done. Let's see.
If this oxygen goes up, then you need to start managing Delaware and New York and New Jersey, since the coastal currents are coming down. All
Okay.
that excess
Yeah.
the nutrients.
Excellent idea. Yeah.
Right?
So this far open. Oh, really?
The gradient current comes down, so we have to start.
What I think, I did not forget, I did not close this one. This is a problem, you have to close the previous one because it does not open the same files 2 times. Okay, let's go. Finished. Finished. Okay, let's see, here. Done. Okay, 25. It's here. Go back here. Let's see code exercise 6. Okay, now I think we just do the way we did it. We just change this one. And now is AC and ABAC. Okay. Ta-da. You are right. And improved, I think, kind of significantly. Right? It's much better. I think the concentration is kind of significantly higher than. So, yeah, open boundary is important. Okay. That's the conclusion.
Any TA can help me on
Oh, sure.
the second.
Actually, I think we're relatively fast. Okay, I just return back to the base case. Instead to mess up with the next exam. Okay. So you decide when we kind of terminate when finish lines. I think we won't be able to do all of them. It's up to you to call. Okay, today is enough.
I mean, don't ask me. If the class feels like we've got enough to get the point of this,
Yeah.
we'll go for a beer.
Yeah.
What's the opinions?
Be good.
I'm giving you the right thumb drive this time.
I want to see that someday. You're
That
gonna see.
Before we wrap up for today, last opportunity for questions or comments before we. So you've seen how to do these sensitivity runs. You get the picture of how it is. You now actually have experience, on the cloud, so you could. Not easily, but you could run the actual Bay model up there, right? I mean, you have some experience with that. You see how to do it in the Windows environment. Does anybody have, last opportunity for questions or comments?
Maybe I misunderstood that. Is there any resuspension term for the sediment?
There is not.
Okay.
That's a real, I mentioned things that frustrate me, and I said I've never done a phosphorus model, and we really should parameterize that resuspension term properly. I know people who have tried to actually connect this to a sediment transport model and have dynamic resuspension. It's a bitch. I'm just,
Having been
they
one of
have
those
really
people, Tom,
dug a hole from which they can't dig themselves out. I mean, it just ain't easy. But I think we should do better than, well, I think it's around 10%. And just for example, before I ran out of time, what I did was I took a map of bottom shear stress, because we compute bottom shear stress to do sediment transport. And I tried to relate that net settling to bottom shear stress, so that empirically, where you have a lot of bottom shear stress, you're going to have a lot of resuspension, and where you don't have a lot of shear stress. But what that empirical relationship is, I have no idea. I just started guessing, and I ran out of time before I guessed right. But
But did you see higher shear stresses in the shallows compared to the deeps, or?
I can't say, Jim.
Okay. Right.
I don't want to say offhand, but
Yeah.
Mark Noel drew me a map of like median bottom shear stress, something like that. And I tried to relate the net settling to that, but how do you relate, you know what I mean?
Yeah.
It's just guessing by golly, and I never made the right guesses, and I ran out of time. But I'm really frustrated by this net settling, and I think we can do a better job than we're doing now, but I haven't done it, and I pass the task on to the next generation.
Is there any map of bottom velocities? You got a map of bottom shear stress. Is there a map of
I've
bottom
never created
velocity?
one could.
But you could make one.
But the shear stress is effectively something times velocity
Yeah,
squared.
or so,
yeah.
yeah.
And it will also depend upon the bottom composition too. And again, the model doesn't take that into account, but the real world would. You have sands versus silts and clays versus gravel versus rocks.
If we brought a benthic ecologist in here, but he'd say, "What are you fellas messing with that shear stress crap? It depends on the benthos, because there are things in the bottom that go, dirt." And suck it, being a little facetious, but a lot of the transfer of organic matter from water to sediments is biogenic. There were worms and things that actually do filter the water column, and we've totally neglected that. We're looking at this strictly from a physical standpoint. We relate it to depth, or we try to relate it to shear stress, or something. But then there are other things totally out of our.
Well, that's the other thing. I guess you got rid of the benthic model and just model oysters now.
Yeah.
And was that because of computational burden, or it just didn't work that well, or?
It didn't do anything.
It didn't do anything.
They were like indicators. Some time ago, we got really interested in a phase of this model. We got really interested in living resources, and one of the things we modeled was benthic informa. And I forget the species. I won't go into it, but benthic informa. So that went into the model, and it was in there, but although we modeled the abundance of benthic informa, they didn't do anything. Like, for example, as Dominic explained yesterday, benthic informa are responsible for the mixing of sediments, but we never made that link.
True.
They just sat there.
Yeah.
And they did, effectively consume carbon and excrete other forms. And I actually kind of looked at that and said, I don't really know what they're doing. You know what I mean?
Mm-hmm. Yeah.
What impact are they having? So in the name of simplicity, if we have something that either does nothing or does things we don't understand, I just decided, let's take that out. It just didn't make sense anymore.
And the SAV is still in there though, right?
And the oysters are still in there.
Yeah.
And do they do anything?
Oh, yeah.
They take out a lot of stuff, and does that affect the other parameters in the model?
Yes.
So if you put the oysters in, you have to change the other parameters in the model.
Well, no, when you say affect other parameters, I think I thought the question is, does it affect the water quality? Yes.
Yes, but does it affect the other parameters that you used to run the model?
Well, but you probably changed them, may have changed them a little bit when you put it in. But
Yeah.
once they're in, they're in.
Okay, so if there are further questions, you ask them over a beer. Ask them at the bar, you know?
A bar to recommend?
Can't we walk over to, isn't there a place kind of across the street from the Bay program?
Oh, the Black something or the
Yeah,
Black
there is.
Lodge?
Boatyard.
It's what?
It's the boatyard.
Can we get a drink at the boatyard? I mean, if we
Oh, the Boatyard.
I mean, in terms of we're on foot, whatever,
Yeah, no.
it seems to me that'd be the closest and the best place.
I forgot there was a place in there. Yep.